Hello students, in this lecture we will learn that what is Joule Thomson effect and what is Joule Thomson coefficient. Okay, so for learning the Joule Thomson effect, let's learn first of all that what is throttling process, because this Joule Thomson effect is particularly applicable for whenever a gas is throttled. So in throttling process we can apply the Joule Thomson effect. Okay, so what is it? Let's learn first of all what is throttling process. See, in case there is a duct or conduit through which some fluid is passing, and that fluid is a gas, okay, a gas is passing, okay, then what happens in case the gas is passing through some restricted passage? Okay, this is a valve which you can close or open by just moving it in up and down direction. Okay, in case you are moving it up, it is opening, and in case you are moving it down, it is closing. Okay, so what happens, that fluid always flows from high pressure to low pressure. Okay, so what happens, this is a restricted passage, so fluid streams are just moving like this through this restricted passage. Okay, this valve is actually restricting the path, and then like this moving from pressure P1 to pressure P2. This process is called as throttling process. Okay, whenever any gas passes through some restricted passage from high pressure region to low pressure region, then this process is called as throttling process. Okay, we know this thing that the energy content of a moving gas can be talked in terms of the enthalpy content. Okay, so initially enthalpy content is H1 and finally enthalpy content is H2. Remember, in case of throttling process, the enthalpy of gas at the inlet of throttling process is exactly equal to the enthalpy of gas at the exit of throttling process. Okay, in case this throttle valve we are considering at the inlet, in case the enthalpy is H1 and at the exit the enthalpy is H2, then H1 is exactly equal to H2. However, here we are talking about the throttling of gases, but one of the example is whenever water passes through a faucet. Okay, in the faucet there is a knob, okay, which can be closed or open or partially opened. Okay, according to that the flow rate of the water can be controlled. Okay, so what happens, before the faucet the water is at high pressure, and after the faucet the water is at low pressure. So this movement of water from high pressure to low pressure by that knob of faucet, we can consider it as a throttling process. Okay, now what happens, that in case we are throttling an ideal gas, okay, in case we are throttling an ideal gas, then the temperature of gas before throttling and the temperature of gas after throttling remains same for an ideal gas only, because we know this thing, for an ideal gas the enthalpy is always a function of temperature. Okay, so in case enthalpy is not changing in throttling process, so the temperature will also not change for the case of ideal gas. But in case of real gas, this doesn't happen. Okay, suppose the real gas is entering to this throttle valve. Okay, this is a restricted passage with pressure P1, and finally the pressure becomes P2, which is lower. Okay, at the inlet the temperature is T1 and the exit is temperature is T2. So what happens, in case a real gas is throttled, okay, then after throttling its temperature can rise, fall or remain constant. You can see anything can happen. Only with real gas, that after throttling process its temperature can rise or its temperature can fall or no change can happen. So how to find out that thing, that after throttling what will happen with that gas? Okay, that experiment was done by the scientist Joule Thomson. Okay, and what that experiment was, Joule Thomson did an experiment with a real gas, throttling of a real gas, and plotted a curve, a throttling line. Okay, a throttling line was plotted between the temperature and pressure axis. You can see this is isenthalpic line, okay, and which is the throttling process line. Okay, this x-axis is made up of pressure and this y-axis is made up of temperature. Okay, now what happens, this is one of the isenthalpic line of that throttling gas. Okay, means over this line everywhere the enthalpy is constant. Okay, now suppose the gas is initially at pressure P1. Okay, you can see this line is going like this, having negative slope initially, and then ultimately reaches a maximum. Okay, and then again the slope of this line changes to positive value. Okay, negative slope and then positive slope. This is what the curve which was obtained by the scientist when the throttling of real gas was carried out. Okay, now what this line tells, okay, suppose the real gas is at pressure P1 and the temperature at that time is T1. Okay, over here there is some enthalpy. Now in case the real gas is throttled to pressure P2, P2 is lower than P1. Okay, so what happens, in that case the temperature will be T2. So what we see, that initially the temperature is T1 and finally the temperature is T2, which is higher than initial one. See, T1 is over here and T2 is over here. So according to this line, that if the gas is throttled from pressure P1 to P2, then temperature rises. Okay. In case the same gas is throttled from pressure P1 to this P3. Okay. So now the low pressure is P3. In that case, the throttling line says now the temperature is T3. Okay, and you can see T3 is smaller than T1. Okay, so what we are observing, that it depends that the gas is throttled from which pressure to which pressure. Okay, if it is throttled from pressure P1 to P2, you can see the temperature is rising. In case the same gas is throttled from P1 to pressure P3, then temperature is falling. So it may cool down or it may heat up. It depends from which pressure to which pressure the throttling process is happening. Okay, I am taking some values for easy understanding. Suppose I say that the gas is at pressure 40 bar. Okay, at that time, according to this isenthalpic line, the temperature is 30 degree centigrade. Okay, now it is throttled to 30 bar. Okay, 40 to 30 bar, then the temperature becomes say 50 degrees. So you can see the temperature has been raised. Okay, now in case the same gas is throttled from 40 bar to 7 bar, you can see at 7 bar the temperature is 50 degree. So again, at 40 bar the temperature is 30 degree, at 7 bar the temperature is 50 degrees. So gas temperature will rise. But in case it is throttled from 40 bar to 3 bar, what you see, at 3 bar the temperature is 20 degree. In this case it will cool down. In case it is throttled from 40 to 3 bar, the temperature becomes 20 degree, so it cools down. Okay, and in case the gas is throttled from 40 bar to 5 bar, what you see, that for 40 bar according to this isenthalpic line the temperature is 30 degree, at 5 bar also the same temperature 30 degree, so no change in temperature will take place in case the same gas is throttled from 40 bar to 5 bar. Okay, so this is what Joule Thomson effect is. And one more thing you can see, that this curve, anywhere in case we want to find out the tangent of this curve, then dy by dx gives the tangent. So according to this graph, dt by dp will give the tangent. So this is what called as Joule Thomson coefficient. At any point in case we are finding the tangent of this curve, that is what Joule Thomson coefficient. Enthalpy remains constant over this line. Okay, so what you see, that this curve also have its maxima. Okay, so over here temperature is maximum, there is a maximum temperature beyond which the gas temperature will not go. That temperature is called as inversion temperature, or also called as maximum inversion temperature. So what we can conclude, that in case throttling process is happening toward right hand side of this maximum inversion temperature line, this red line, right hand side, then always the gas temperature will rise. Okay, from here to here you can see temperature is rising, 40 to 30 rising. For an example I am taking these magnitudes, up to 15 bar you can see the temperature will always rise. Okay, so throttling process carried out over pure right of this inversion temperature line, the temperature will always rise. And in case throttling process is happening over pure left of this line, means suppose the gas is at 7 bar, temperature 50 degree, it is throttled to 5 bar, temperature 30 degree. So it will always cool down in case the throttling process is carried out toward the left hand of this red line, inversion temperature line. Okay, and in case the gas is throttled from the right hand side of this line toward left hand side, then it depends. You can see if it is throttled from 40 bar to 7 bar, the temperature is rising, you can see. And in case the same gas is throttled from 40 bar to 3 bar, the temperature is falling. Okay, so this is what Joule Thomson effect is. Okay, and I also told what is Joule Thomson coefficient. So by this small lecture I hope you would have understood what is Joule Thomson coefficient and what is Joule Thomson effect.